Hello and welcome back to another organic chemistry series video. In today's episode we're going to be discussing E and Z absolute configuration. Let's get right into it. So in the alkene video we briefly discussed cis and trans isomerism. In this episode I'm going to show you why that system can be pretty irrelevant at some points, and why the E and Z geometry, the absolute configuration system, is a lot more important in plenty of more instances. So the first case here, cis, we have R and R prime on the same side of the molecule. They are cis to one another. Cis and trans are very important when we're discussing disubstituted alkenes, and so that we can say that R is cis to R prime. Or, in this case, this group is cis to this group. But that same rule applies if you want to say this group, the methyl, is trans to the H. And now, we will see why when using EZ absolute configuration, why that is wrong, and how, in this instance, this is trans. You're classifying this as trans to something else. But in reality, this will be Z geometry. We'll get into this in a later minute. So like I just discussed with cis isomerism, trans isomerism is the same exact thing. It's used for disubstituted alkenes, and it's approximating one group to another. It is not absolute, and so in this instance, we can say this R group is trans to R prime. I hope you can see this. We'll move into why EZ, the EZ system, is a lot more easy to denote a molecule. Let's get right into it. So looking at this example, let's use both systems, the trans-cis isomerism and the EZ absolute configuration. Fluorine is trans to the other fluorine, but in accordance with the EZ absolute configuration system, this fluorine gets higher priority over this H, but this bromine gets higher priority over this fluorine. And this is because the atomic number is lower. Fluorine's 9, bromine is 35. Fluorine is 9, hydrogen is 1. And so in accordance with the EZ absolute configuration system, this would be a Z double bond, meaning it's on the same side of the double bond, the two higher priority groups. I hope you can see why this is more important when looking at a double bond to classify something with the Cahn-Ingold-Prelog convention and using the EZ absolute configuration system, and why it's just a little bit more important than the cis and trans, and how it's different than the cis and trans. So let's look at one more diagram here. This is just to clear it up, to put the whole picture, bring it all together. This would be Z because the higher priority groups are on the same side of the double bond. A good way to think about this is Z same side. Now Z and E are rooted in German, they're from the German origin. I'm not going to get into that. It's not something you're going to be tested on. They're not words you're going to have to memorize, so don't even worry about it. It's Z and E. Z, same side. E, opposite sides. In this instance, in this diagram, we're looking at an E double bond, E absolute configuration, because the higher groups are on opposite sides of that double bond. I really hope you can see the picture now. Now let's get into some practice problems. Denote some things as E or Z, and then we'll throw in a couple nomenclature problems so you can see how to incorporate it into a name. So let's hop into this first example. We're going to just denote this as either E or Z. The first thing you want to do when given a problem like this is split the bond and look at the molecule of the double bond from the right and the left side. So let's look at the left side first. We're comparing Cl to a carbon. I say this because you want to look at what the carbon, the double bonded carbon, is attached to. And say they are the same. We'll get into this later. Say they're the same. You want to keep going atom to atom of attachment point and seeing when an atomic number differs from the other. And if it's a higher atomic number, therefore it gets higher priority. In this instance, the chlorine is going to get priority over the carbon. On the right side, the carbon gets priority over the hydrogen. Therefore, this molecule is a Z double bond. They're on the same side of the double bond, the higher priority groups. All right, so our next example, split the double bond. Look at the left and right. Doesn't matter. Let's look at the right side first. This carbon, the double bonded carbon, is attached to a carbon and another carbon. Now this is the instance where you're going to want to go another atom out or another atom out. So just keep going until you find a point that's different. We're comparing CH2 to a CH3. This carbon would be compared to a third hydrogen. Therefore, it gets higher priority. So let's look at the left side of the bond. This carbon is attached to a carbon down here, which is just a methyl group, so 3 implied hydrogens. Up here, we're looking at another double bond. And now, when presented with a double bond that's attached to a carbon from the initial double bond that you're looking at, you double whatever atom is attached to the other side of that double bond. In this instance, it's a carbon. But if it was say like an oxygen, it's going to make things a little bit more interesting depending on what's on the other side, what you're comparing it to down below. In this instance, it makes it just higher priority because double the carbon, it's going to be a higher atomic number than what would ever be down here, which are the 3 hydrogens. So this gets the priority. Looking at another Z double bond. Now this example, let's get right into it. First thing you got to do, split the double bond. And then look at the right and left side. Same thing we've been doing. But this case is a little bit more interesting because we're presented with the same thing on both bonds. So in this instance, E and Z, the system is negligible. You don't have to worry about it because they're the same thing. You're comparing apples to apples. All right, so one more example. Split the double bond. Now look at the left and right side. Let's do the left side because it's pretty easy. Bromine to a hydrogen. The bromine gets priority. Now, from the right side, this is a case with a double bond that makes it a bit more interesting. We have a carbon attached to a carbon on both bonds. And so we have to go another bond out. The next bond out from this carbon is 2 bonds to an oxygen. Therefore, it would be like doubling the oxygen. You're going to see this notation from your professors. And so we're comparing carbon, oxygen, oxygen to a carbon, oxygen, hydrogen. And so therefore, this top group gets priority. So a Z double bond. So before I close out this video, let's discuss one nomenclature problem. Remember the rules of nomenclature? You want to number the longest carbon chain. In this instance, it's an alkene, so you have to include the double bond. So let's number 1, 2. Are we going down or up? We have to go up because it's the longer carbon chain. 4, 5. Denote your substituents. We have a bromine attached to C1. We have an ethyl attached to C2. And so how do we name this? Well, first, before we get into that, let's look at this from our EZ absolute configuration standpoint. You're not going to have to denote EZ all the time. It's whether the problem or your professor wants you to. But in the actual chemical field beyond college, it's definitely a huge factor in naming molecules. And so it's something you want to get good at. So split the double bond. Bromine gets priority up here. This carbon chain gets priority over here. So we're looking at another Z double bond. So let's name this. We have 1 bromo. 1 bromo. I usually always capitalize the first letter. 1 bromo. 2 ethyl. 2 ethyl. Now, show the double bond. 1 Z pentene. 1 bromo, 2 ethyl, 1 Z-pentene. So you can also name this like this. This is all up here. This is, pretend that's all included. You could do pentene like this. Pent 1 Z-ene. Really depends on how you were taught. Both are acceptable. So if this video helped, leave a like, subscribe. Let us know in the comments what you want to see from us. And have fun doing your orgo, your cell biology. We'll see you in the next one.